Okay, we're ready to start our testing. The generator's all set up. This will be 1000 volts, 100 microsecond full width, half height, 2 ohm source impedance. We'll do both positive and negative transients in every mode. Okay, we'll go ahead and functional test it. You're looking at 500 volts per division, and this is 50 microsecond per division. Let's see again, roughly 100 microsecond full width, half height, 1.5 kV. Okay, again this will be 1.5 kV, 100 microsecond full width, half height, 2 ohm source impedance, 5 transients, each mode positive and negative. Okay, that's it. We'll go ahead and check it out. Okay, the meter looks good. So just to give you an idea here, the 1 kV testing, the BK2705B had failed. The UTL DM2 failed. The Southwire 12070T failed. And the Innova 3320 had failed. At the 1.5K level, the Amprobe AM510 failed, and the Tech Power TP40 had failed. So next up, 2000 volts, 100 microsecond full width, half height, 2 ohm source impedance, 5 transients each, positive and negative per mode. Okay, we'll go ahead and functional test it. Okay, the meter held up just fine. This next test will be 2.5 kV. Okay, that's it. I'll go ahead and functional test it. This will be 3000 volts. Okay, it looks like it might be okay. We'll functional test it. Okay, it actually passed that. Next up, 4,000 volts. Get some of these out of the way. Alright, that's it. We'll go ahead and functional test. Yeah, it survived the 4,000 volt transient. So I've got it set now for 5,000 volts. This is again the paper that was supplied with this meter. That I'm not quite sure what this is, but you can see 21st October 2015. Again, I purchased this off of Amazon like the last one. I believe that this was shipped directly from UNI-T to Amazon. So I believe it's current. If I look at the circuit board revision, it's Rev 4. The meter that I tested previously was also a Rev 4. If I look at the footage that I took of the original 139C, it looks identical to this one. So it's not like they changed out the PTCs. You know, the resistors all look like they're the same. So the original 139C failed with a positive 3.7 kV transient. It was in the diode test mode. And you could see, and I don't know if you remember, maybe I'll splice in some footage of that, but it had overheated some traces and it blew out a PTC. This is looking inside of the UNI-T 139C. You can see there's some discoloration up here. Oh yeah, look at all this. When I flipped it upside down, yeah, that's all the crap that just came out of this meter here. Yeah, the more I'm looking at it, I think that that's all off of this PTC here. Yep, I think that that was encapsulated like this one. But anyway, I suspect the 4 kV on this one must be within inside of the margin of what the meter could have handled. So this will be a 5,000 volt transient, and I'm not going to be too surprised if this damages the meter. Okay, here we go. Here the LaCroix caling. Of course, I just saw another transient. Okay, this is the mode where it failed at before. And unfortunately, I think it just failed again. Let me just stop the transient test right now. Let's see if this thing comes back. Yep. Yep, this is what happened to the meter before. So it's definitely been damaged. Let's just check some of the other modes. Yeah, when I tested the meter the first time, I actually ran it through all of its paces, so it did quite a bit of damage to the meter. So it's hurt the capacitance and the resistance modes and the continuity check. And you can see here if I did short it. Yep. See, I suspect when the meter was tested the first time and it failed at 3.7 kV, I ran this one at 4. It survived. You know, 5's a pretty big step. I thought that it would probably take it out, so unfortunately it did. Okay, this bottom row here, this is the UT139C. And we can see we ran the PCO grill igniter test, passed fine, ran the maximum DC voltage test, in this case it was 600 volts, passed that fine, ran the rectified 200 volt, and that passed fine. And then we started running the transients, and it made it all the way up to 5,000 volts where it failed. If we look at the whole peak HP760H, it also failed at this same level, and the previous one broke down somewhere around 3.7 kV. Again, it looks like the 2 meters were identical. At least it looked like they had used all the same components between the first one that I tested and this one. They're definitely the same revision circuit board. So I think before we do anything more with it, we'll have a look and see if we can figure out what exactly failed. When I blew the previous one up, this trace right here was overheated. So I suspect maybe Q8 and Q9 are probably what's failed. Brian to the rescue here. Okay, so you can kind of see. So if we look at these diodes right here, say Q8, I don't know, could be a transistor. Let's have a look. Yep, dead short. And let's see this one here. Yep. That one's bad. And this one here. Yep. Look at the second one here. My guess is these are bad too. Oh, well, that's interesting. It appears that Q8 and Q3 are both shorted, but Q2 and Q9 are not. So yeah, it appears again Q8 here and Q3 here were both damaged. We'll just put this thing back together and we'll see if it works. Okay, so I checked out all the parts in this area and I don't see anything else wrong with it. When I fired it up, the diode check now works, and originally after it failed, if you'd measure the voltage between the two inputs, I was reading about 1/2 volt. After replacing the two diodes here, this goes up to 1 volt, which would be normal. You know, and I can look at that volt signal and I can see now that routes all the way through the MOVs, everything up through this protection, and unfortunately it goes up here and into our chip. So yeah, I believe I looked at all the values here, nothing shorted, all the resistors appear to be the right value, so it's unfortunate. So we'll put it together one last time, and I think we're going to run a few additional tests with it. So this is in the ohms mode. You can see it's reading a dead short. However, if I look at the output voltage now, you can see it's reading 1.01. This is on par with what it read originally. After the meter was damaged, this was reading about 0.5 volts. The two diodes that I had replaced right here, these are both shorted, and it clamped it basically to the rail. I checked both rails that those clamped to, and those seem correct, so no damage there. So after changing out the diodes again, this voltage came back to normal. You can see here it reads a short in continuity. The diode check, though, actually works now. So this is with a dead short and open. This is with a single diode, 2 and 3 diodes in series. And the capacitance mode also does not work. Normally this would read about 250 picofarads or so. Again, this is the second 139C I had tested. The original one failed quite early in the test. This is the Amprobe AM510. This went on to be the semi-finalist against the Fluke 101. I've put this meter back to what it was originally when it was purchased. Again, this meter had been damaged, hit 5.8 kV. And what I'm going to do is I'm going to repeat this test using the new generator set to the same settings that we just damaged the UNI-T UT139C at. And we'll see if this meter will survive this. My guess is that it will, because this is a lower voltage, but yep, let's just give her a shot. Okay. Just do a basic checkout here. Should be roughly 14.5 or so volts. Looks fine. Should be roughly 5 volts off our reference here. Looks good. This is a 10 meg. Looks good. 1 meg. Looks good. 100K. Looks good. 10K. Looks good. 1K. Good. 100 ohms. Looks good. 50. Looks good. 1 ohm. Looks good. Here's 1 diode, 2. This thing can't read 2 diodes in series. That's funny. Yeah, that thing's fast. Okay, let's try capacitance. So again, this would be a 0.1 microfarad. Looks good. 1 microfarad. low. 10 microfarad. It's a little low. I'm not sure if I ever caled that when I had this meter apart or not. And let's see here. Frequency. Yep. And duty cycle. Yep. So I finished checking out this meter, but it looks fine. So one of the interesting things about the 510, again, this was the runner-up in the first round of testing. This actually does better than this AM530 does. For robustness, yep, this 510 once again proves itself. Based on the testing that we just completed, I'd say this 139C probably is on par with the first one that I tested. I believe that the very first 139C probably would have passed all the first tests right along with the other meters up to the point where it failed. The fact that this one failed between 4 and 5 kV, that did not surprise me at all, you know, based on where the first one failed. We didn't see the damage to this meter, but of course I stopped the testing as soon as I'd realized that we had damaged it. Again, we did attempt to repair it. Unfortunately, I believe the main control IC has been damaged, so there's nothing I can do at this point to repair this meter. The big surprise to me from running this is, you know, I pulled the old 510 out and I repeated the tests. And I was kind of wondering how this meter was going to do anyway, because when I ran this 530, it actually failed pretty early on in the tests, where this 510 went quite a long ways in the original test. And sure enough, this thing repeats. So this meter, this 510, actually holds up a lot better than this 530 does. So just because you buy a meter and it's in the same series as another meter, don't expect them to have the same robustness. So yeah, for 50 bucks, you know, is it worth it to buy this meter? I don't know. I mean, it's really up to you. Again, you know, you saw what I ended up buying. It's this Bryman here. You know, this meter will survive all these tests with no problems at all, and then some. Plus, it has higher res, you know, slew of other features. None of the meters I tested could even do basic AC plus DC measurements. So to me, you know, for my home use, this is a good meter. It doesn't cost all that much, you know. It's well worth the price. But really, this UNI-T actually held up quite well. It's held up better than any other UNI-T meter that I've tested. When you compare this with the UT61D and E that I looked at, you know, this thing is just way ahead of those. Of course, those two meters have data logging. This doesn't have it. So, you know, pick your poison. Of course, the Bryman can do data logging. So I hope the video was informative and that you enjoyed it. You know, it answered some questions for me. It does give me a little bit of faith in the UNI-Ts anyway. You know, seeing that this thing actually held up at least as good as the first one did that I tested. You know, I probably wouldn't take them a whole lot to improve on these, and this thing would probably run right along with this guy. The fact that they don't have any cutouts in the circuit board, the fact that there's no high voltage resistors in it. So anyway, till the next meter.